everybody. I'm D.Lebrero. Thanks for coming. And we are here today to talk about REPL Driven Development. But before we get started, I have a confession to make. On my very, very first job as a developer, I got to work with 3 technologies that made a profound and lasting impact on my career as a developer. Those 3 technologies were Netscape, Internet Explorer 4, and Internet Explorer 5. Thanks to those 3 technologies, I decided to become a back-end developer, avoiding any kind of front-end work for a lot of years. And I have been a very happy Java developer, living in a world of XML and JSON. But on a recent project, I got to work again with a front-end team. And I have to confess that since that day, that project, I'm actually very, very jealous of the front-end developers, up to the point that I'm contemplating the possibility of becoming one of them. You may wonder, well, isn't that crazy? Why? Maybe the JavaScript that these developers were using was somehow different from the JavaScript that I have to learn and suffer 20 years ago. JavaScript is evolving, but that is hard. It's still the same JavaScript. Maybe they have fixed all those incompatibilities between browsers that used to drive me crazy. It doesn't seem so. It seems that they are there, and now with all the phones and tablets, it's even worse. To really understand why I'm so jealous of the front-end developers, let's look at a picture of myself doing some front-end work. That's me, trying to get a 2-column layout working on Internet Explorer and Opera. And as you can see, I'm not very good at it. And as much as I try, and I try, and I try, the result is always the same. It's just a big pile of crap. But even if CSS doesn't make any sense at all, there is something really nice, there's something really powerful on that picture. So let's look at it again. Focus on Mr. Griffin's workflow. See how he pulls the string in one direction, and he sees straight away, with any kind of delay, what's the result on the blind. And if he doesn't like it, he just pulls the string in a different direction. And he keeps doing that until he's done. Is this immediate feedback what I'm really missing on my day-to-day job as a backend developer? We know from Agile, Scrum, Lean, that feedback loops are very important. But why is this immediate feedback so important for us? Because without this immediate feedback, it's very difficult to get into the flow or the zone. The flow is that state where you feel like Neo when he comes to realize that he's the chosen one. When you are in the flow, you are so focused that the real world disappears and is replaced with your code, its design, and the data flowing through it. When you are in the flow, no problem is difficult enough. No bug can hide from you, and your solutions are clean, simple, and elegant. When you are in the flow is when you are your most productive. And it's not that you just produce more. What you produce is of better quality. But this productivity is just a nice side effect of being in the flow. What we are really looking for is that feeling of joy, that feeling of achievement, that feeling of creating something beautiful. And it's this feeling why I am, after 20 years, still a software developer. But we all know it. You are there in the flow, completely focused, doing all your tips and tricks. And then, that sounds familiar. That's how little it takes to push you out of the flow. And we backend developers, we are experts at these kinds of interruptions. We do them all the time, and we think they're unavoidable. We even have comics about it. But probably we have a laugh at it because we maybe don't know what's the cost of one interruption of getting out of the flow. There are a couple of studies that try to quantify what's that cost. And it seems that it's every time that you are interrupted, you waste between 10 and 15 minutes to get back the context of the task that you were doing. So it takes you 15 minutes to start coding again. And the worrying thing is that if you look at what usability experts say, if you want to keep your train of thought, interruptions cannot be longer than 1 second. And if your interruptions are longer than 10 seconds, it's quite probable that you will end up playing with your phone or checking the news or looking at your social media. And who here is able to build, compile, start the runtime in 1 second or less? while preparing this presentation as a test, I created a new Tomcat application using the company's archetype, completely new, and I just timed how long it took the project to build and start. The project just had one controller doing nothing and one test doing nothing. Who wants to give a guess how long it took for the Tomcat to start an empty application? 20 seconds. In my case, it was 30 seconds, so it's quite good. And is 30 seconds a long time, or is 30 seconds a reasonable amount of time? So let's think for 30 seconds about 30 seconds. Okay? Are we ready? Those were 30 seconds. And I don't know how it felt for you guys, but for me, standing up here in front of all of you, those were very long 30 seconds. And we do this all the time. And this is not going to get any better, right? As we add more tests, more code, this is just going to get worse and worse and worse. But, you know, we know this. So probably if you want to keep yourself productive, you are already following the advice of that very wise man. So what you do is you don't run your application. What you do instead is you rely on a good unit test suite to know if you are making progress and to know that you didn't break anything. And remember, and this is curious, that a good test suite, it has to run in 10 seconds or less. So if you look around and you look for a number, it's 10 seconds or less. Because if it's more than 10 seconds, we probably will lose focus. Now, you have been doing TDD long enough. You probably know that TDD has some shortcomings. So let's look at them. Who can tell me what mocks, stubs, fakes, and spies have in common? What are mocks? Mocks are just lies. What are fakes? They are all just lies, right? They are lies that we create to keep our test suite really fast, to get our workflow, to keep our workflow sane. But they are just lies. They're not the real thing. Now, I think we cannot avoid them, but what we really want is credible lies. We want to create our mocks that they behave as the real thing. But how can you do that? To be able to mock the real thing, you really need to understand how the real world things works. And how do you do that? Well, if you are talking with a database, the only way that I know is going and poking at the database, looking which tables are there, which columns, what are the possible ranges of values in those columns. If you need to integrate with a third-party HTTP RESTful endpoint, the only way that I know is going there and poking at that thing. And this is something that TDD doesn't give us any kind of tool to be able to go and understand how the real world works, so we can go and do our mocking. Now, I have been doing TDD for 16, 17 years now. And one thing that I'm learned is that no matter how many tests you have, what's your code coverage, there are always some bugs. You start the thing, maybe your configuration is not there or it's not correct. Maybe your Spring wiring is not exactly the same as your unit testing. So it's always a situation that you are going to have. And TDD, again, doesn't give you anything when that breaks. So what do we want for our workflow? We want to write code and get immediate feedback. We don't want to be sitting there waiting for the build and the deploy to happen. We want tools to understand the real world, so we can have an easy way of creating faithful lies. And we don't want any surprises when the application starts. What kind of tool we can do to get all of these things? You're not going to be surprised. As REPL, it's a possible tool. REPL stands for Read-Eval-Print Loop, and we have all probably used a REPL, usually in the form of a command line interface. So the console, what it's doing here is reading your command, then it evaluates it, it runs it, and then it prints the result. And then it loops, so it goes back to reading to allow you to put another command. So basically, a REPL is the same thing, with the only difference that instead of writing Unix commands, what we are going to be doing is writing small pieces of code that are going to be run in our program. So we're going to do a demo. And what the demo is going to do is we are going to use Maven to start a Tomcat. The Tomcat is going to start our application, our war. And inside the war, what we are going to do is start a REPL inside our application. Now, because typing things in that really small screen is really cumbersome, the REPL, instead of reading from the standard input, what it's going to do is going to be listening to a socket. And then from our favorite IDE, we're just going to connect through a socket to that socket. And we're going to be writing code, where we always write code in your IDE. We'll use a shortcut to send code to the application. The code will run inside the application, and then we will get back the results that will be printed on the bottom window. Okay, so we'll write code where we always write code. Shortcut, it executes inside the Tomcat, and then we see what's the result of that execution. Okay. Now I'm going to do the demo in Clojure. Clojure is right now my favorite language. Clojure is a Lisp for the JVM, and the point of the presentation is not about Clojure, so I don't expect anybody to understand any of the code, and I'm not going to explain any of the code. So the only thing that I want you guys to focus is on the workflow, on how, with a REPL, we do all the tasks, and I wanted for you to compare it with how will you do it at work. Now, one of the reasons to have a REPL, that most of the languages have a REPL, it's to be able to learn the language. It gives you a tool that it makes it a lot easier to learn a language because it's easier to play with it. So I'm going to add another item there that is to learn the language. So let's go. So the very first thing that we are going to do is we are going to start the application. You don't see much. It doesn't matter. So this is the first thing that if you have a good REPL, before even writing or thinking about what you're going to write, the very, very first thing that you do is start the application. This is usually the slowest bit of all the workflow, and usually takes around 30 seconds or so. And now, this is something that you will do once a day, or maybe once a week, or once a month. I personally have a REPL running more than 3 months. So this is depending if you need to change projects or not. You will try to keep it running all the time. So what we are going to build is a small RESTful application that what it's going to do, it's going to go to the database. It's going to get some transactions from a user, and it's going to do some kind of summary, and it's going to expose that on an HTTP endpoint. So now that we have the application running, what we are going to do is from idea, I'm going to click that button, and hopefully, big enough. Okay, so now we are connected to that REPL. Yeah, remember that the REPL is running inside the Tomcat. So we are going to learn, I promise you, just a tiny, tiny bit of Clojure, but this is so you guys get used to what I'm going to be doing all the time. So in Clojure, everything, you have to put a lot of parentheses, a Lisp. So the first thing on a list is the function that you want to call, and then 0 more parameters. Now I'm going to hit the magic shortcut, and I'm going to send this particular piece of code, I'm going to send it to the Tomcat, and the Tomcat is going to return me the response. So you see here, down here, what I send. So I send 1 plus 2, and I got a 3 back, yeah? So again, I'm going to do it again. So I change it, I hit a shortcut, that's been evaluated inside the JVM, inside the Tomcat, and the result is printed up back. Questions? Is it clear what my shortcuts? Because I'm going to be doing it all the time. So let's say that you want to learn a little bit more about the plus function. What happens if you pass 3 parameters to the plus function? You just write the code, you run it, and you see that the language allows you to do that. What happens if you just pass 1 parameter to the plus function? It also works. What happens if you pass no parameters? It returns 0. What happens if you pass a very long value? Seems to work. Let's go for a longer value. It throws an arithmetic exception. So what we are doing here is just trying to understand how the plus function works, right? And how we are doing it is we make small changes, we write small programs, and each of them we run them, and we see straight away what's the result. The same way we are doing it with the plus function, that's part of the core language. You could be doing it with absolutely any library that you wanted to explore. So this is enough Clojure. I'm just going to do another so you guys see it. Clojure, you're going to see that there are hash maps. They look quite similar to JSON. So, for example, this is a map of the key F to 34. And this will be another one, ADF to 99, yeah? So this is a map, this is like JSON, okay? Everybody says the JSON there. So these are literals, called literals, and we're going to see them all the time, so this is just for you guys to know. Cool, so that's the end of the Clojure for you guys. So we have been just learning a little bit about the language, playing a little bit with it. So now we are going to build the application for real. So again, what we are going to do is we are going to go to database, and for a given client, we are going to get a list of all these transactions, and we are going to do something very simple to summarize all those transactions. So the first thing that I want to do, or we are going to do, the first thing that we want to do is just connect to database. Just check that our configuration to the database is correct. And to do that, we just try to do select one from dual. So select one. Yeah. And if you know Java, it's telling you there is no suitable driver for Postgres, so we forgot about that. So if I go to my POM, we see here that I forgot to uncomment it. And the usual thing that you will do is like, well, you uncomment the dependencies, and you restart again the JVM to see if things work. But instead of that, the JVM is able to load code from anywhere, and it's able to do it at runtime. So what we're going to tell the JVM that is running inside Tomcat is just, well, can you please go to Maven, download all dependencies for the Postgres driver, and just install it. And then we just try it again. Now it seems that we get another exception, but this one is different. Database doesn't exist, and this is because I make a little typo. So we change it, and you see that right now, you see the results here, yeah? We are connected to the database. So what are we doing? We're basically testing our configuration. I don't know how you do it, but for me it's usually very painful because when you have to test things like configuration, you have to be constantly restarting the JVM to see if it works, if it finds the file, if it doesn't find it, if you put the credentials correctly or not. But here we are able to do it in an interactive way. So what are we going to do now is going to explore the real world. We are going to go and say like, okay, we don't know anything about, we know the database, but we don't know what's inside the database. So what I usually will do is open something like Postgre, Oracle, SQL Developer, and then I will put the credentials, and then I will start navigating and looking in the UI to see what is in there. But instead of that, what we are going to do is using the JDBC metadata API. We're just going from the Tomcat, we are just going to query the database, and we are going to ask the query, well, can you please give me all the tables that start with transaction? So if we run that, we see here that Postgres is returning us 3 objects, 3 maps. Instead of printing it like this, because it's a little bit difficult to read, because we are on the JVM, we are just going to write a function so we print this in a more tabley way. So this is a little bit easier to read. Yeah. So we have here table called transaction. Probably this is the table that we want to use. And what we are going to do is we just make a query to database with a bunch of results. And here we will see, there is a currency, there is an amount, there's some timestamp, an ID, client ID. So we get an example of the data that is there. Now, we realize that the currency, there are 2 currencies. So probably if we want to summarize this thing properly, we need some kind of forex exchange. So we go to our architect and we ask him, like, well, I have this problem. I have euros in one side, GBPs in another one. So what do we do? And he said, like, well, we have a RESTful endpoint somewhere that you can hit, and it will give you the Forex exchange. So he gave us the URL, and we are just going to poke at that RESTful endpoint. So if I run this, I'm making now the HTTP request. This is failing somehow, so what we are going to do is have a look at what's the error. Okay, so that's the error. So it's saying that it's 400 is returning that endpoint, and if we look at the body, it says something like the date is missing. So let's add to our request, query parameters, date. Let's get today's date, or now. If I run it again, we see now that the body is returning some JSON. We are in the good path. So let's extract the body. Extract the body, that looks good. And let's parse the JSON. And that's it. So look at what we are doing. Look at the flow. Just what we're doing is we write one little piece of code and we run it immediately, and we see the result. And we do it for each and every small step. Now we probably want to check, okay, do we have data that is old? Seems that we have data. It's data that is very, very old. Seems that we don't have data before 1970. What happens if for some reason we send ask for data in the future? Oh, we have data in the future. That's a very interesting feature. What happens if we pass a string? We get an error saying that the date should be along. So we're exploring how the thing works. And now, for example, we know how errors look like. So now we can go and build our logic around handling errors. Now, when you are building this, your team lead comes and says, like, well, you know, there is already some store proc in the database that is going to do all this logic for you, so don't pay attention to architects. They don't know anything. So you go again to database like, well, I didn't know that. So what we're going to do, it's again exactly the same thing as before. We're going to ask the database through the JDBC, metadata API, which store procs we have that contain the word trans. And we say that, okay, we have transactions in GVP. So let's have a look again. What's that store proc about? So we see that it returns a cursor, and it requires a client ID. So that's good. So now what we could do, we know how or what the store proc accepts and what it requires. And what we could do is now write our code. You know, JDBC calling store procs is just hell. But what we are doing here, at the end of the day, is just we are printing this thing as a table. But why we need to print it as a table? We can also print it as a piece of code. So I print it as a piece of code. I copy this, paste it, and now give it a try. Does it work? Seems to work. What happens if I pass a client that doesn't exist? No value. What happens if I pass nil? No value. What happens if I pass a string? An exception. So again, we are just, poking around to understand how things work. Now you may be wondering, well, why is this any better than using Oracle SQL Developer? Right? That's a SQL-specific tool. What is this thing? This piece of code that we just generated. This is our first piece of production code. This is production code. If we were using SQL Developer, we will know what to do, but now we'll have to go and type the code to be able to call the database. And that code, you will need to test it because you don't really know if it works or not. But how likely it is that this store proc, when we deploy it, when we run it in the application, it fails, it doesn't work. Well, if you think about it, every time that we evaluate, every time that we send a piece of code, we are sending it inside the Tomcat. So basically what we are doing is deploying that piece of code into the Tomcat. So it's very, very unlikely that this code doesn't work. Now, I haven't explained it, but where are we making these changes? Well, there's maybe to be small. But we are making the changes. This file is not a special place. This is the project file. Once we are finished with the work, what we will do is just commit this file as it is. We are not have to copy this code into another place or do something. This is production code. This is how we will go, and it's in the correct place. Now, another reason why you would want, or you can want, to use a REPL instead of SQL or Postman, it's how many people know how to do a for loop? Nobody knows how to do a for loop? Yeah. How many people know how to do a for loop in Postman? I have been told that it's possible. Yeah, but we do for loops all day long, right? If you have a REPL, you have the whole language. Your production language is not a different language, it's your production language to do everything. So here we're just looking at the transactions for the first 10 clients. The same way, because we are in the JVM, what happens if, for some reason, for your investigation, you needed to get data from database and somehow correlated it with this with an HTTP service? Well, if you are using Postman and SQL Developer, maybe you will need to export the results into CSV in both cases and maybe create some bash script. But again, we are on the JVM, so just writing a little piece of code to do that for us. And because, again, we are in the JVM, and the JVM has libraries for absolutely everything, we can get more fancy. And if we really, really need it, we can also do graphs, right? There are plenty of graphing libraries in the JVM. So here, again, we have all the tools of the JVM at our disposal to understand how the real world works. So let's say that we have finished this exploration phase to understand how the real world works. And now what we want to do, we want to switch to our TDD workflow, right? So the first thing that we'll do is write a test. This is a test. And if you see, it's saying that, okay, it's failing, but that's because we didn't provide it within any data, any mock data. Now we could go here and type all the mock data. But if you think about it, well, we are calling the DB. So one option is just to copy the results from that DB call, and when we run it, that's 42. How likely is that this data that we are using in our test is not, it has a typo, or it's not the right type? Well, that came from the database. So out of our exploration work, we are able to get that pieces of data and use them straight away in our test. Okay, so let's say that your business manager, product owner, says that we don't want for our summary function to take into account records with type 101. So if you're doing TDD, first thing that you will do is, okay, the expectation should be 18. You write the test, you see it fail, and now you want to make it green. So we'll go to the code. We'll remove the types, and we'll run it again, and it's green. Cool. So we have implemented what we were asked for. Now let's say that the business manager also says, like, well, you know, we don't want to count negative numbers because they look very bad. So it's 23. And you run it again, and now you go to the other file and you make a change. But this switching between files is a little bit annoying, right? So what we're going to tell the REPL is to keep track of all the changes that we're making in the project and run the test as soon as we save the file. So if we save the file now, yeah, we got this thing wrong. Let's remove. It's running the test automatically without me having to do anything. Yeah. So if I change the test, I change it back again. So it's running the test. And the nice thing about this is that it's not just running all the tests. If I go to a file that has no tests, see what it says here. Well, I didn't run any tests because this file doesn't have any tests at all. So it's not just going to run all the tests, all your test suite. It's just going to run the tests that could be affected by the change that you made. So let's say that we finish. I'm going to cheat a little bit. And now we're happy with our business logic. And the only bit that we are missing is to create that restful endpoint to expose this function to the external world. This particular service is using Swagger. Everybody familiar with the Swagger? Swagger is just like a JSON definition of your endpoints. So then you can do things like consume it. In this case, the one that is consuming that JSON definition is a Swagger UI. And this Swagger UI, what it just draws the API endpoints, and it allows you to easily type things and see the result. So let's add our new endpoint. And what we do is we're going to just copy the previous one. We call it total. Let's see if that works. Refresh. Oop. So we see now the total is here. This is our new endpoint. Let's, instead of who, we require a client of type long. Let's see if that works. That's it, client of type long. And if we pass a number, this obviously doesn't work because we haven't implemented anything. So we're going to do our wiring. And what you will do with your Spring wiring, what we're going to do is just call the database, that function that we created. And let's give it a try. Total 23. Yeah. I personally don't put or try to avoid put any kind of logic on my controllers. So I usually don't test them. And what we have done here is we have just tested that the wiring actually works. Let's say that apart from the total, you want to return the client. We could go and check it here. But this, again, changing from one tool to another to do your testing is getting annoying. And the JVM, I'm pretty sure that it's able to do HTTP calls, right? So we write a little piece of code that is going to make an HTTP call straight away. So now, if we change the client to account to confuse everybody, see, it changed automatically. And we don't need to change, to another tool. If instead of account, we wanted then a client, oops, we see that the changes appear and we can check it without having, the feedback loop is immediate. So now we have all this, automatic refreshing of state and code and everything. But what happens with the state? We have here a piece of state that is just we're going to use it to count how many HTTP requests this service has consumed. So what we are going to do is we are going to delete everything and we are just going to return a counter with the number of requests. If I test that, it says here 1, yeah? So let's test it. 1, 2, 3, 4, 6, 7, 10. Yeah, we have 12. Now we are going to change this. So what happens when I make changes? The counter, that piece of state, has gone back to 0 to 1. What's happening is when the code is refreshed, we are losing that state. That's maybe something that you want to do, but sometimes it's a little bit annoying. So this is, for example, when you're doing you have some caching, and you're testing the caching, and loading the caching from database takes forever. Losing the state of the cache is really, really annoying. It just slows you down. So what we can tell the REPL is that, well, for this particular piece of state, I don't want you to destroy it when there's a change. So let's increase again the count, 7, 8, 9, 10, 13, 14. If I make a change, 15. If I make a change, 16. Yep. So we can selectively decide which piece of states we want to keep. And it's not just that we can decide which piece of states because we are really inside the JVM. We can go and we can inspect the state. Any state that you have in your application, any state, you can go and poke at it. You can, if this was a cache or a hash map or whatever, we could just go and see what's inside that hash map. It's like debugging, but inside the REPL. The same way that you can inspect it, you could go and just change it. Let's try, if the state is very long, it's a long number. What happens if I have a very long number? It throws an exception. Yep. So we are able to inspect and destroy, and we can selectively decide what state to keep and which one. We don't care which state can be transitory. But sometimes, even state that you think that you don't want to get rid of it, you want to get rid of it, for example, now. So there is a way of telling the REPL, oh, get rid of everything, even the things that I told you not to get rid of. And then, if you look at the counter, we look at the test, if we make the HTTP request, we see that the counter is back to normal. And the same way we are inspecting state, we can also pick up, or we can, any state that's going through your application, you can capture it. So for example, if I want to capture what was the last client that was called, I just do this thing, and then I have a variable called xxx, where I say that the client, this particular piece of state, the last time that was called, had the value 1. And because we have, again, your production language, this could be within an if statement that can call the database, or can inspect what is there, or it can check what are the headers of the request, so you can do whatever you want to do. Cool. So enough of that demo. So what do we got from our REPL? We learn a little bit of Clojure, just a little bit. So we were writing code and getting immediate feedback about if it worked or not and what was the result. We just have to start the application once, and as I said, this is something that you will do maybe daily, maybe weekly. We have all the JVM libraries to explore the real world. And the nice thing about the JVM is you have libraries for absolutely everything. We were using the results of our test, the results of our exploration directly on our test. I'm not going to say that you're going to get no surprises, but for sure you are going to get less surprises when you start your application, because you are able to test more things. As a bonus, we saw that we can add libraries to the running application, that we can get and improve TDD workflow, because we can tell the REPL to run just the test that can be affected by a change. We saw that we can inspect, manage state, and touch it, and do whatever we want to it. And this is a big bonus for me. We did all of this within IDEA, within your IDE. So you don't need to be switching from one tool or another. Now, if you think about it, the REPL is listening on a socket. And things that are listening on a socket, it means that you don't really need to run them locally. So what will happen if we leave this REPL with the socket open in our staging and production environments? And then from our ID, we connect it to the staging or production environments. How many times you have had a bug reported, and you think, well, if I could just look at the state of this particular object in staging, I will know straight away what was the issue. I will be able to fix it straight away. Or how you have thought, oh, if you just add one log line, I will know what's happening because I will know what's the state of this thing. And then you make that change of logging, you deploy it again, and you realize, oh, and it wasn't exactly this the log line that I wanted. I wanted a different log line. With our REPL, we are able to make all these changes immediately in whatever environment you want. But who will be so crazy to want to have this kind of power in production? It's just too dangerous, right? So in 1999, the NASA debugged and fixed a concurrency bug in a spacecraft that was 100 million kilometers away. And they did it because they have running a REPL in the spacecraft. And notice that they say I fix it, so they would change the running code on the spacecraft. So if I'm going to say that if the NASA have this power in production, probably we can also use it. You have to be extremely careful, but why not? So all the things that we said, I'm going to do that 2 more. The bug, staging and production, and we can control spacecrafts. Oh, sorry. Just 30 seconds, don't worry. Just the second time in 1 hour. How many times you try to rebuild per hour? Just 30 seconds. Come on. Come on. Remember why we do this. You do it for your joy, and you do it for the productivity of your company. As I said, this is not exclusive to Clojure. There are videos for similar things in different languages and environments. Now, each REPL is going to have different capabilities. They are not equal, and they are not all equal. So you are going to see slightly different things of what you can do with it. What about the Java 9 REPL? This is me when I read that the Java 9 REPL was going to get. Java was going to get a REPL. But at the end, if you read what the aim of the Java REPL is, they just want to make easy to learn the language. So of all the list of things that we saw that a REPL can give you, Java 9, 10 and 11, REPL, they're just aiming for the very first one, that is make the language, make it easy to learn the language. But if you look at the Java 9 REPL, it's funny because the language is not exactly the same, right? The Java 9 REPL have different semantics, different syntax, while in more powerful REPLs, you get the whole language. There is no change, exactly the same. Some references, if you haven't seen the second Brett Victor, Invented by Principle, if you haven't seen that talk, please go and watch it. This is the talk that opened my mind about what kind of tools we should be using for our own work, and it's just mind-blowing. And with that, I'm done. Thank you very much for your time. Any questions?
Is there any specific plugin that runs and sends the code to the Tomcat?
What you do is on your application, just start a REPL. So that's, in the case of Clojure, that's a library. So you, as part of your dependencies, when you start the Tomcat, you say, oh, I want to depend on this REPL. And then you have in our case, we have a Spring Bean saying like, oh, start a REPL. Start the REPL in this port. And then on IDEA, I'm using Cursive. Cursive is the Clojure plugin for IDEA. And as part of that plugin, you get the REPL connection and everything.
Thank you.
Thank you. I have a question. Is it possible to develop, for example, desktop GUI applications using the same approach?
Yes. If you saw what we did in the demo, we actually created two,
Yeah, I understand, but it was...
But at the end of the day, one of the... you can do it. That's no question. And in fact, in the videos, you will see people doing this in Android applications and on iOS applications. So people are connected to their phone when they are developing, and they're evaluating the code, but they're evaluating inside the Android application. And they're generating, they're just adding buttons on everything. You can do the same in desktop. Now, to make some of the stuff easy, like for example, being able to keep the state, it means that you need to use React-like patterns where you keep the state in one place. So when you reload, you just reload in the code, and then the triggers are re-render of the view. So you have to use a more functional pattern to allow some of the characteristics, because if not, you end up with a mess. But there is a very cool demo there, Arcadia. What's the thing that used to do games? Unity. There is a demo there where there are some guys connected. They connected a REPL into a Unity running engine, and they were writing code and seeing, everything fall into place. It's called Arcadia. It's. So this kind of experience, it's just amazing. I have used it also, for example, I have been doing big data, so you can do it with Spark. You can do it, you can connect to our Kubernetes cluster. We have all these things running, and you can connect to anything and just poke around with things. Any other questions? Thank you very much for your time. Cheers.